Okay, we will continue with the midterm overview of the FCT. Guys, the first step or the key to go through this, I know it's not easy. I know. We are not joking if we said this is gonna be easy. It's not easy, but it's gonna make your life a lot easier if you just go through every detail and you collect them all together. And don't give up. Just don't give up. Just don't do it. You will have to understand everything carefully. Just think, we are talking about a vector space with the details of a basis, coordinates, everything, every little piece of information, it's worth it. And it's going to be working together. So, with a good understanding from all of this, now you can see such a beautiful piece like this example. He's stating that common information to the following two questions. So, these questions or this information can be used for the two common questions. The first of them, he introduces to you a matrix, which is 3 by 3, as you can see. Consider the vectors, and he supported you with a couple of vectors. So once you go through something like this, please don't be afraid. Just read it step by step and be easy by yourself. So that's a matrix. It is what it is, 3 matrices, and it's giving me from D1 up to D5. And he really announced this information will be used with a couple of questions. The first question is asking here. The matrix A, is it diagonalizable? Wait a minute. Where did we hear about diagonalization? Wait, it's on the eigenvalue, eigenvector. Yes? So now I'm starting to think. I will need eigenvalue, eigenvectors. All eigenvalues of A have algebraic multiplicity. I will have to evaluate the eigenvalues. Okay. Of which matrix? A matrix. So now I'm sure that I will have to get them first. Okay, 3 is an eigenvalue of A with geometric multiplicity, blah, blah, blah. I will have to get them. The last one, the question after that. One of the eigenvalues, stop, I'm not going to read anymore. I will have to go first to get what? The eigenvalues and the eigenvectors. How to get the eigenvalues and eigenvectors for this problem? I will get the elements of the principal diagonal minus number. I will solve them. And I will try to get the values of this. I will just keep it to you as short as possible because I have a lot of things to talk about. So if I want to get the eigenvalues of this problem, just in case if you don't remember how to get it, also I would recommend don't go through this lecture unless you really studied what's previous. Okay? To make your life a lot easier. So if I want to get the eigenvalues, all I have to do is to get the equation which states that A minus lambda I equal to 0. So I will take 3 minus lambda, then negative over 5 and 0. For the second row, it's going to 0. Negative 2 minus lambda equal 0. For the last one, it's going to be negative over 5. A positive 5, negative 2 minus lambda. And all of this, I will put it equal to 0. Now I will try to expand this equation in order to get the values that I told you about. So all I have to do is to multiply the elements of the principal diagonal using substitute, if you remember. So it's gonna be 3 minus lambda times negative 2 minus lambda, but to the power of 2. This is the multiplication of the principal elements of the elements of the principal diagonal. Then plus 5 times 0 times 0 is 0, 0 times negative 1 times negative 1 0. This is 0, this is also 0, and that's 0. So the result overall equal to 0. So now you have lambda equal to 3, and also you have lambda equal to what? Okay, this is negative 2, 2 minus 2, am I right? But it's already repeated how many times? 2 times. So the algebraic multiplicity of negative 2 is, and the algebraic multiplicity of lambda equal to 3, it's gonna be repeated once, repeated twice. These are the algebraic multiplicities of either 3 and negative 2. Okay, now I can get the eigenvectors. you remember how to get the eigenvector? It's really very simple. All I have to do is to solve A minus lambda I times U, which is the eigenvector, equals 0. It's a homogeneous system. So all I have to do is to make a re-substitution, okay, in this matrix. So I would say for 3. 3 minus 3 is going to be 0. Then you will have negative 5, 0, and 0. For the second row, it's going to be a 0. Negative 2 minus 3, so it's going to be negative over 5, 0, and then leave 0. The last row is negative 5, yes? 5, and the negative 2 minus 3, which is going to be a negative over 5, and also equal to 0. Start getting as close as possible for a reduced echelon form. How to do this? All I have to do is to get the last row in replacement of the first row. So all I have to do is to get the following. I will replace the third row in order to be the first. So it's going to be, and also I will divide on negative 5. So it's going to be 1, negative 1, 1, and 0. Am I right? Okay, then multiplying by, okay, dividing on negative 5, so it's going to be 0, 1, 0, and 0. And for the last one, I will multiply this row by 5 to add it on the first row. So the last one is going to be all zeros. The last step, I can add the second row on the first row. Am I right? Yes, add the second row on the first row. So you will end up having what? You will end up having 1, a 0, a 1, and it's equal to 0. For the second row, 0, 1, 0, 0, and all the elements are zeros. So if you try to expand it, you will have x plus 0 over y plus z equal to 0, and also you have y equal to what? To 0. Okay, the main eigenvalue vector, which is, let's say, the main eigenvalue vector that I'm interested in evaluate is u, which consists of how many components? Am I right? Okay, now you know the conditions. The first condition is x plus z equal, which means x equal negative z. So this value is negative z. And the y value should equal 2. And the last is, so taking z as a common will give you the span of this eigenspace, which is negative 1, 0, and 1. With algebraic multiplicity, with geometric multiplicity of 1, because it's just only one vector. Am I right? Okay. This is exactly what have been done in here. So, get the eigenvalues and the eigenvectors in order to analyze this problem. This is the first step. Okay, this is the matrix that we spoke about. Okay, getting the equation. Solving the system of this cubic equation, which is going to involve lambda equal to 3 and the lambda equal to negative 2 with 2 multiplicity of 2. Getting a vector for either negative 2 or for a lambda, so this is the value of negative 2. I will do exactly the same like what we did, but with negative 2. I've ended up having the condition that's going to be 1, 0, and negative 1. And also, of course, Zaina remarked that if I have negative 1, 0, it's also right. And if I have 2, 0, negative 2, it's right. And if I have 2, 0, negative 2, it's also the same. Because I can take numbers out in or out. Okay, solving for negative 2, you will end up having 1, 1, 1 with 0, 0, 0, and 1. Here, the geometric multiplicity, how many vectors? 2 vectors. Do you know how to get them? Similar manner. But by the end, you will have one equation in how many variables? So once you start making this substitution, you can separate this vector into how many vectors? 2 vectors. Your eyes telling me that you don't know what I'm talking about. If I want to solve with respect to negative, I will do it this time for you. Because I want to show you also to review on how to get these values. بص في الكاميرا كده شوفي ده كفرت. بص في السكوب بتاع الكاميرا شوفي ده كفرت في الموضوع هنا ولا لازم نزقه شويه؟ لا. ها؟ لا ما تزقوش حضرتك. باين صح؟ طيب حلو. خلاص خليني كده 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 اوكي برضه عشان النور. باين. بصي كده. اخر فين؟ يعني ما تحركهاش ليه؟ ممكن حضرتك تيجي كده شويه. كده؟ لغايه هنا باين؟ لا هنا مش باين. تمام. كده باين. تمام؟ اوكي يلا تاني وانس مور. انا هبدا بالسيستم، السيستم كان بيقول ايه؟ السيستم اللي انا كنت بشتغل عليه دلوقتي كان بيقول A minus lambda I times U equal كام؟ equal 0. طيب فين الماتريكس؟ ايه الماتريكس بتاعتي؟ اهي هفتحها ادي الماتريكس واحده واحده. Then I will use now the value of lambda equal to negative 2. Make the substitutions. So 3 minus negative 2, so it's gonna be 5. Then I will have negative 5, 0 and 0 for the second row. It will start with 0. Negative 2 minus negative 2. So it's going to come to, then I leave 0 and 0, am I right? The last one, which is going to be a negative over 5, a positive over 5. Then negative 2 minus, okay, negative 2 minus positive 2, which is going to be a 0. Are we all right? Yes, okay. Adding the first row with the third row will leave you with 0, 0, 0, 0. Am I right? 5 plus negative 5, 0. Negative 5 plus 5 equal to 0. 0, 0, 0. That's all. The second row is also 0, 0, 0. The first row, which states that 1, negative 1, 0, and 0. I'm talking about the second eigenvector, or the second set of eigenvectors, yes? Which consists of first x and y and z, am I right? The condition states that x minus y should equal to, which leaves you with x should equal to, okay, done. Let's do this. So it's gonna be y, and z, am I right? Which can be written as y, and 0 plus a 0, 0, and z, am I right? Once you take these elements, you will find the span of the eigenspace. And in this case, it will be 1, 1, and 0, am I right? And the other vector is 0, 0, and 1. And this is the eigenspan that we are talking about. So with geometric multiplicity of, and also the algebraic multiplicity, previously you had it equal to what? To 2. Am I right? Okay, exactly. This is the two vectors that we are talking about. More than perfect. Okay, let's see. The matrix A is not diagonalizable. Is it correct or not correct? Okay. A matrix A is diagonalizable. ليه diagonalizable؟ لأن الالجبريك multiplicity بتساوي geometric multiplicity for all of them. الالجبريك بتاع 3 ب 1 والجيومتريك بتاع 1. الالجبريك multiplicity of negative 2 ب 2 والجيومتريك بتاعها كام؟ ب 2. حلو. يبقى إذا the first is not correct because it is not. He's stating it is not diagonalizable, but it is diagonalizable. Okay? Okay. بيقول all eigenvalues of A have algebraic multiplicity of 1. Is this true? No. Because one of them has multiplicity of 2. Okay. The third one, 3 is an eigenvalue of A. هل 3 is an eigenvalue? 3 is an eigenvalue. Eigenvalue of A with geometric multiplicity equal to the rank of the matrix A minus 3I3. No, it's not correct. Although it's an eigenvalue, but it's not correct in this statement. Okay, one of the eigenvalues of A has geometric multiplicity of 2,
added together تبقى 1 1 1.
بيرفكت. يبقى إذا ده كونديشن مظبوط جدا. وكان ممكن أعمل حاجة تانية من زي ده. I can review this statement, check this statement. If A times V equal lambda times what? Times V. So if you check this condition, multiplying A, this is the A matrix, times 1, 1, 1, you will find the value equal to one of these values. -2 times in V, which is 1, 1, 1, which is correct, which means that it is really correct. Okay. For the second question, this is the second question. Also giving you the same question with a bunch of alternatives. He's stating for you, indicate which of the following subspaces are eigenspaces of matrix A. Okay. I think this 2, yes, am I right? Okay. These are the eigenspaces that I got. So 1, 1, 0, 0, 0, 1, which is D1 and D2. So I'm suspecting this is the correct one. C is correct. And also 1, 0, -1. Okay. And also G, which is stand for D3, which is 1, 0, and -1. So actually this is the second question. As you can see, it's related to the first. All you have to do is to get the set of eigenvalues and eigenvectors. For the third and the fourth question in this part, in this exam, it was about chapter 8, and it's not going to be involved in our exam. Okay? For this one, he's stating, indicate which of the statements is true, and he's giving you, if you have G, a linear transform from R3 into R2, there is such that XO is giving you the function. Yes? It's giving you the function. XG, which is the function, moves XYZ into a 2 dyne, which is X minus Y, Y plus Z. So it's giving you the F function or the G function. Okay? For all XYZ belongs to it. Then -1, -1, 1 is a basis for the kernel of G. Opa. He's asking you about the kernel. Do you remember how to get the kernel? Also, number B is stating that R3 into R4 is a linear transformation, and is this going to be equal to each other? And there exists a linear transformation of R3 to R4 such that F is injective, and the image of F has the dimension of 2. We will have to load this to the test. The linear T Rn into Rn, which is a transform moving from Rn to Rn, is a linear transformation. Then T is surjective if and only if T is injective. It's true. So it's going to be surjective if it is just only injective. We will see. Okay, the last one, there exists a linear transformation R3 into R4 such that 1, 0 T belongs to the kernel of H, and the image of H is given by these conditions. It's really each statement should be studied carefully. For the first one, which states that it is R3 into R2, and he's asking you about the kernel of this transform. How to get the kernel of this transform? What I have to do is to take the image. Can you see the image? X minus Y, Y plus Z. Put it equal to 0. So it will give you X equal Y and Y equal -Z. Take these conditions and substitute in X, Y, Z. It's related to. So for A, use the kernel G means put the image into 0. So once you put X minus Y, Y plus Z equal to 0, you will have the conditions. That X should equal Y and Y should equal to -Z. Make the substitution. Okay? So once you make the substitution, replacing X by Y, replacing Y by -Z, you will have the -Z, -Z, and Z, which can be put on the form -1, -1, and 1. So the first is correct. For the second one, R3 into is a linear transform. So I'm moving, let's wait. I'm moving 2 vectors, the addition of 2 vectors, and I have another movement for another 2 vectors. And I'm asking you if the images are equal. The problem is I'm not giving you the function. Yes? Oh, how to check that? Oh, wait. Let's get the sum of these 2 vectors. This is a linear transform. Didn't he mention that? What do you understand from a linear transform? A closure under addition and a closure under multiplication by scalar. You have now a closure under addition. What if we add these two vectors together? Let's add these two vectors together. 0 plus 3. 3. 1 plus 1 equal? 0 plus 0 equal? Let's try the left hand side. 1 plus 2.
3.
1 plus 1. 0, 0. Oh, so it's the same vector. Yes? And it's already correct. المفروض انت تساليني تقولي لي هو اشمعنى يعني؟ وانا قبل ما اموف هجمعهم مع بعض اقول لك ما هو linear transform. اول relation to linear transform ان the addition of the function equal the addition of the images. So it's already exists. Since it is a linear transform, the identity and homogeneity is satisfied. If you have the function of this vector, you add it, you will get f of 3 to 0, which is not equal to make sense. Okay, perfect. Okay, if I want to see, and he's stating that if you have, there is a linear transform R such that f is injective, and the image of f has dimension 2, it's not going to be injective. Not simply because to be injective, the kernel of f should equal to 0. And it will be with dimension 3, not 2. صح؟ وانت لازم تجيب الانرجي كده. تعال نرجع نفكر تاني. هو بيقول لك ايه في نمبر سي؟ بيقول there exists a linear transformation f moving the stuff من R3 into R4. يعني انا بحرك من R3 مين؟ ل R4. حلو. Such that f is injective. And the image of f has dimension كام؟ 2. طب تعالى نفكر بقى. طيب هو انا الترانسفورم بيحركك من R3 ل R4. عشان يبقى انجكتيف لازم الكرنل يساوي كام؟ 0. بس لازم تبقى من الدايمنشن اللي هو 3. لان انت بتجيب الكونديشن هنا بتحط الزيرو تجيب الكونديشنز تعمل سبستيتيوشن في مين؟ يبقى لازم يبقى ده في ار كام؟ مش ار مين؟ صح كده؟ يبقى اذا ده الستيتمنت not simply because to be injective kernel of f لازم يبقى كام؟ مش ده شرط الانجكشن؟ طيب عشان يبقى injective and it will be with dimension كام؟ 3 لان انت بتجيب الصوره في R4 وتروح تعمل سبستيتيوشن في R3 لازم الدايمنشن يبقى ايه؟ 3 بس هو دلوقتي بكام؟ 2. طيب بصي على النمبر دي ده Rn to Rn a linear transform and T is subjective if and only if T is injective. Yes, since the linear transform is from Rn into Rn, it is injective, it must be subjective. لان they have the same dimension. Okay. Number E, there exists a linear transformation R3 to R4 such that 1, 0, T belongs to the kernel of H and the image. خلي بالك, since it is true or false question, so the answer is no. This is not correct. But this is need further analysis. If I want to do the analysis of this problem in specific, I will have to go step by step. So the first step, he is asking you, if there exists a linear transformation H R3 into R4 such that 102 belongs to the kernel, so I will have to check first if 102 belongs to H. And if it already exists and the image is given by this set of vectors. So for the vector 102 to be the kernel of H, then H of 102 should be image at 0, mapped be 0. يعني عشان يبقى 102 ده kernel لازم يبقى ال 102 لما اعمل الترانسفورم بتاع اتش اللي هو مش معاكي اصلا يبقى ده هيروح يمد هناك في مين؟ في اورجن ولا ايه؟ صح؟ يبقى اذا ده لازم يبقى. This means 102 is mapped to the zero of the vector in R4. يبقى ده بيظهر هناك في مين؟ 000 صح؟ طيب كمل. الايمج كونديشن اللي هناك عندك فيها كام فيكتور؟ 1.01 0020 001 نيجاتيف 1 دي الايمج هناك في R4. طيب بيكمل يقول دي 3 فيكتورز ار لينيرلي اندبندنت يبقى ينفع ان هم يكونوا بيزس مش كده برضه؟ اوكي form a basis for the subspace F which is belongs to R4. Thus the linear transformation of R3 to a 3-dimensional space of R4 is possible. يبقى اذا ده معناه ان ممكن بالفعل ان انا انقل من R3 ل R4 ودي تبقى البيسس مين؟ بتاعته صح كده؟ حلو قوي. فاضل بقى ان انا اكمل construct that transformation. انا هعمل assumption ان ال 102 بيروح لمين؟ للاوريجن عشان يبقى الكيرنل موجود. بعدين هفترض ان 010 هحتاج مع ال 102 ده هحتاج كام فيكتور عشان تو سبان الدومين to another linearly independent vectors. انا I will guess them. معايا؟ مين الجسس بتوعي 010 001؟ لو قلت ان 010 بيمد into 1001 و 001 بيمد into 0020 that's a linear set enough ان انا to have the image of the codomain. Okay, verifying the transformation. The kernel condition is satisfied. ده already موجود. The image condition is satisfied because the set اللي هي 1 و 2 3 forms a basis for the image of H. يكونوا image هناك. طيب ده معناه ان thus linear transformation H exists with the desired properties. بس انت هنا مش بتعملي analysis how to move. انت بتشوفي هل الداتا اللي انا مديها لك enough ولا لا؟ من ناحيه انه ينفع بس under the assumption ان ال H بتمال الاليمنت ده into 1001. هل دول عندك؟ لا، يبقى خلاص ما ينفعش. This is why although the logic is correct, but it's not supported over here. It's just telling you that there exists a transformation such that ده بيروح لمين؟ للكيرنل، اوكي؟ بعدين and the image بتاعت ال H is supported blue. بس انت you are not sure about H, is not giving you H. لذلك يبقى الريزلت بتاعتك هنا بتساوي اوكي خلاص ده الاكسبلانيشن in details. طيب بالنسبه للكويشن نمبر 6 in question number 6 بيقول in R4 consider the subspaces F, A, B, C, D belongs to R4 B minus D equal to 0 و A plus 2C equal 0. يبقى انا هنا مديلك الكونديشنز اللي تقدر تطلعي بيهم البيزس. بعدين مديلك الجي البيزس بتاعتها يبقى تاني وانس مور. انا بدي F R4 consider the subspace. ده السبسبيس F اللي هو بيتكون من A B C D. دي الكونديشنز الفورمينج. مين الكونديشنز الفورمينج؟ اللي B equal مين؟ D او الميك this substitution. وان A equal negative 2C او الميك also this substitution. بالتالي اقدر اطلع منهم 2 vectors or more دول البيزس بتاعت السب فيكتور سبيس. او انا اعملها دلوقتي. اوكي؟ استني وده الجي دول ال 2. هو بقى عايز يقول ان these conditions which are the following statements true or false. The first of them هل 2010 0101 is a basis for F؟ هل ده basis for F؟ ما لازم تجيب البيزس بتاع ال F. اجيب بيزس ال F ازاي؟ زي ما انا قلت لك دلوقتي. بصي. Number 8 to see if it is a basis for F. First of all just use the conditions. مين الكونديشنز؟ ان انا اروح على ده اشيل البي واحط مكانه مين؟ يبقى ده دي ودي. بعدين اشيل الاي واحط نيجاتيف 2 سي يبقى ده نيجاتيف 2 سي دي سي دي. لو انت قسمتيهم يبقى نيجاتيف 201 والتاني اللي هو 0101. هل دول اللي انا مديهم لك شايفه واقفه على مين؟ نيجاتيف. يبقى اسمه اوكي. ده سكند بيقول في نمبر بي الدايمنشن بتاع الاف doesn't equal للدايمنشن بتاع مين؟ الجي. وده دايركت ستيتمنت مش صح لسبب لان انا دلوقتي لما جبت الستيتمنت كان دول كام دايمنشن؟ وهل اصلا ديك الجي فيه كام دايمنشن؟ صح؟ يبقى هما الاثنين بيساووا ايه؟ بس هو هنا ماله؟ يبقى ده مش صح. تعالى على نمبر سي. نمبر سي بيقول لك if plus g equal R4 لان ده فيه كام؟ 2 وده فيه كام؟ شفت بقى؟ الاجابه سهله قوي. بيساوي 4. طيب نمبر اللي بعد كده دي بيقول A B C D belongs to R4 يبقى A بيساوي 0 و B plus C equal to 0 يعني كده انت عايز تجيب البيزس بتاع ده وتشوفيها هي دي ولا مش كده برضه؟ which is easy. Get the condition from the basis A negative C C and D which could be 0 negative 1 1 0 وكلهم 0 1 والاثنين دول اوريدي موجودين عندك فوق. هتقولي لي بس ده اهو لو عملت ده نيجاتيف ضربته عملته تايمز نيجاتيف واتس possible so it's correct. وده 0 0 1 هو انا بقول 0 0 ايه؟ اقدر كان take 3 as a common so it's correct. Okay. يبقى ده مظبوط. The last one F intersection G equal to 0. انت معاك البيزس معلش هنا دي البيزس اهي دي بتاعت مين؟ F ودي البيزس بتاعت مين؟ G. حضرتك شايفه اي intersection do you see common vectors؟ there is no common vectors. يبقى على طول F intersection G يساوي كام؟ 0 which make sense complete sense. صح كده؟ طيب السؤال ده زي ما انا شايف مش صح بس طبعا من البدايه انا اتخيل ان الواحد لو دخل عليه مش بص فيه الديتيلز it's not gonna be easy from my point of view. Okay, so bottom line just to go step by step. This is a beautiful problem. Indicate which of the following statement true or false. If F is a subspace of R3, so here he is talking to you about the inner product of vectors and the orthogonal set of vectors. Now I start to identify in which part I should think. He's stating if F is a subvector space of R3, then dim F plus the dimension of the orthogonal complement of F should equal to 3. So you have to think. Yes, it's correct because both the dimension of the subvector space and the orthogonal property is going to equal to 3. If E1, E2, 3 is an orthogonal basis of R3, then the cosine of the angle between the vectors T is that. تعمليها ازاي كده؟
substitute في الايكويشن الاصليه بتاعتها.
همسك E1, E2, E3 اللي هم 1 0 0 1 0 0 0 1 اسبستيتيوت بيهم هنا. تعرف تجيب الفيكتور ده كام؟ 1 نيجاتيف 2 0 والفيكتور الثاني هيبقى بمين؟ 1 0 1 احطهم مع بعض في الكوزاين. Do you remember the cosine law? Which states cosine inner product by the magnitude of each one. This is the explanation of the first one. This is the explanation of the second. This is E1 minus 2 E2, which is then E1 minus 2 equals 0. E1 plus E3 equals 1 0 1. Just apply the cosine angle V1 dot V2, the inner product, divided by the magnitude of V1 times the magnitude of V2. It's going to be correct. It's going to be equal to 1. Okay, if f x y z and the r belongs to R3 such that negative 3x cy 3z, then negative 3 3 and negative 3 is a basis for an orthogonal. That's a direct question. That's a direct question. All I have to do is to put the condition as a 0. So I'm moving zeta 3z from the right to the left. So it's going to be negative 3x plus 3y minus 3z. The coefficients, the coordinates are the basis of the orthogonal complement. So it's going to be negative 3, positive 3, and negative 3 should equal to 0. Okay? So directly it is correct. It's fitting here. Negative 3x plus 3y minus 3z equal to 0. So the orthogonal complement is correct. So this one is correct. If E1, E2, E3 is a positively oriented orthonormal basis of R3, then 3E1, E2 dot E1 minus E2, all you have to do is to make substitution. So here I'm making a cross product between 3 double 0 and 0 2 0 is IJK, so I'm giving the vector. Then I will make a dot multiplication of the inner product with the vector of E1 1 0 0 0 negative 1 0 0 0 1, add them together, so it's simply 1 negative 1 and 1, and see if the condition that he is stating equal to negative 6 or not is not going to be negative 6. This is E1, E2, E3. Make a determinant satisfying the conditions. Do you read me? فاهمة بقول ايه؟
ايوه
فاهمة ولا لا؟
فاهمه.
طيب هيطلع بكام؟ 6 بس مش هيطلع نيجاتيف 6. دي اسمها الخيال. طبعا الاخير خالص هنا بيقول if E1, E2, E3 is positively oriented orthogonal basis for E, then شوف لي دول orthogonal ولا لا، ودي اعملها ازاي؟ اشوف دول orthogonal، اشوف دول orthogonal ولا لا، وده بالفعل اللي انا عملته. واحده فيهم تطلع orthogonal والثانيه مش هتطلع orthogonal يبقى اسمها correct. اوكي؟ فاكر ده فين بيلعب ايه؟ consider in the vector space R2 صح؟ اوكي the bases انا مديك R2 يبقى انا هنا R2 مديك مين؟ 2 bases مش 1 base 2 bases بعدين بيقول and in the vector space of R3 انا بتكلم على R3 I'm moving from R2 ورايح على مين؟ على R3 R2 في كام فيكتور؟ و R3 في كام فيكتور؟ انا مديهولك برضه كام بيزس؟ I'm sorry 2 بيزس يبقى هنا مديلك 2 بيزس البروبلم اللي انا كنت بشرحها من شويه 2 بيزس وهنا مديلك كام بيز؟ 2 بيزس هنا 2 بس هنا كام؟ 3 اوكي 3 باي 3 يعني I need R3 يبقى ده B1 B1 dash B2 B2 dash he is giving you like a moving stuff from R2 into يبقى دي الماتريكس اللي بتموف من 2 لمين؟ ل 3 of a linear transform a matrix from B1 into B1 dash طبعا reading this problem in such a way I'm just trying to identify in which chapter it's working and in which part. Then it will be deeply recommended if you try to make just a simple sketch like the one that we already did do previously. In these conditions indicate which statement of these statements is true. If this true for this ID, if this true, how to check. If this true, how to check. If this true, and so on. So I will go, the first is correct, the others, and this is the exact solution. Let's see the explanation. First, let's look at A, which removes stuffs from B2 dash into B1 dash. I told you we work from the vice versa, from B1 dash into B2 dash. So now I will see each vector in B1 dash, how it is formed from B2 dash. And the coordinates are 1, 1, and 0. Let's check that. So I will go stating T R3 into